Greetings and welcome to my channel. I am Mr. D the Science Dude, and today we'll be discussing the classification of matter. Matter is the stuff that makes up everything around you. It's anything that takes up space and has mass. We can classify matter in different ways. One way is by using the method that most people use to differentiate matter, and that's by what phase or state of matter it is in. There are three normal states of matter: solids, liquids, and gases. There's a fourth state of matter called plasma that we won't get into at this point, but I'll leave a link in the description below to a video about it in case you're interested. For fluids and liquids, their characteristics are independent of pressure. For gases, we'll see that this is not the case. Matter that is solid is composed of particles that are tightly bound to each other by strong intermolecular forces, and therefore can't move past one another. The particles only vibrate in place. It's for this reason that solids retain their shapes and can't change their volumes. Liquids are composed of particles that are very close together and experience moderately strong intermolecular forces. The particles can't move away from each other, but they can move past one another. So liquids can change their shapes, but they do not experience a change in volume. Gas particles are far apart from each other, and their intermolecular forces are negligible. You can decrease the size of the container, increasing the pressure and bringing the particles closer together. If you increase the size of the container, the particles will spread out as they randomly move around and expand and fill the container, decreasing the pressure. Gas particles can easily move past and away from each other, therefore they do not have fixed shapes or volumes. Scientists classify matter a little more definitively than this. Let's look at these classifications in the form of a chart to help us see the relationships between these different classifications. Matter is divided into two groups: pure substances, or just substances, and mixtures. Substances are uniform throughout and have a definite composition. All samples of a substance will have the same composition and properties. Mixtures are physical blends of two or more substances. Its composition may not be uniform throughout, and the ratio of its constituents may be variable. Let's take on substances first. Substances can be further divided into elements and compounds. Elements are the simplest type of matter. Elements are composed of only one type of atom. The atom is the smallest particle of an element that still retains properties of that element. To give you an idea of just how small an atom is, picture a piece of spider silk. It's 1/10,000th of a centimeter in diameter. 7,000 carbon atoms can fit across that diameter. Few elements are found in their elemental state in nature. Examples include helium, neon, argon, silver, gold, and copper. Some gaseous elements in their elemental form will be present in particles called molecules, which would be composed of two atoms chemically combined. The elements are called diatomic. Examples of these include nitrogen, oxygen, hydrogen, and chlorine. Chemical compounds, or just compounds as you usually hear them referred to as, are substances composed of two or more different elements chemically combined in constant whole number ratios. When a compound is composed of atoms that are chemically bonded together, that's what we call a covalent bond, we call these particles molecules. Things like sugar, acetic acid, which is the acid you find in vinegar, and water are molecular substances. When a compound is composed of charged particles, which we call ions, we use the term formula unit to represent the smallest unit of that substance. It will be expressed in whole number ratios. So table salt, calcium carbonate, and potassium hydroxide are non-molecular substances, and we call them ionic compounds. Alright, that takes care of substances. Let's go over mixtures. As you'll recall, mixtures are physical blends of two or more substances. If the parts that make it up are uniformly distributed, you have a homogeneous mixture. If the parts are not uniformly distributed, then you have a heterogeneous mixture. All homogeneous mixtures are solutions. Two main types of heterogeneous mixtures are suspensions and colloids. Homogeneous mixtures first. All homogeneous mixtures, as we said, are solutions. Solutions are composed of two parts: the solute, the substance being dissolved, and the solvent, which is the dissolving medium or the substance into which we're dissolving the solute. liquid and gaseous solutions are clear or transparent. In the air we breathe, the largest component is nitrogen, so it would be considered the solvent. Oxygen, argon, carbon dioxide, and all the other gases that are dissolved in it are the solutes. In Coca-Cola, water is the solvent, and sugar and all the other flavorings are the solutes. What are the solute and solvent in ocean water? If you said salt is the solute and water is the solvent, you would be correct. In stainless steel, a solid solution known as an alloy, iron is the solvent, and chromium and carbon are the solutes. In these mixtures, the parts are not uniformly distributed. You can sometimes see the individual parts that make up a heterogeneous mixture. Examples of these include salt and pepper, styrofoam and sand, granite, smoke, and milk. They can be separated into their constituent parts using physical means. Things like filtering, differences in boiling point, differences in density. Two of the main types of heterogeneous mixtures are suspensions and colloids. If the particles are too large to stay suspended and settle out over time, then the mixture is a suspension. Italian dressing is a suspension of oil and vinegar, which is why you have to shake it up before you put it on your salad. Paint is a suspension. That's why when you go to the hardware store to get some paint to paint your room, they'll put it in a machine to shake it up and mix up real good for you before you leave. And why they give you a paint stirrer so that you can mix it up before you start painting. Many liquid medications are suspensions. Milk of magnesia and Pepto-Bismol are examples. If you have any younger siblings, your parents may have gotten a prescription for antibiotics filled at the pharmacy, and you'll have seen them shaking it up before giving a dose to your little brother or sister. That's because it's a suspension. Colloids are heterogeneous mixtures in which the particles dispersed in the mixture are small enough to stay suspended. Milk is a colloid. The label may say that it's homogenized, but if you look at a drop of milk under a microscope, you can actually see the little droplets of fat suspended in the watery part of the milk. Sometimes you may have a liquid that you think is a solution because it may at first glance appear to be clear, but if you shine a light through it, you can see the beam of light in the liquid. This is because the beam of light is being scattered by the suspended particles in the mixture. This scattering of light by the suspended particles is called the Tyndall effect. If you've ever looked up in the sky and seen a beam of light through a break in the clouds, this is because of the Tyndall effect. Light is being scattered by the dust and other particles suspended in the air. There are 5 different types of colloids: gels, aerosols, foams, sols, and emulsions. In a gel, long branching particles trap liquids. Gelatin desserts like Jell-O is a gel. In an aerosol, solids or liquids are dispersed in a gas. Examples of these include fog, smog, smoke, and mists. In a foam, air bubbles are trapped in the liquid. Shaving cream would be an example of a foam, as would soap suds. Sols are solids dispersed in a liquid. Ink and blood are examples of sols. An emulsion is a liquid dispersed in another liquid. Milk and mayonnaise are examples of emulsions. A chocolate bar contains an emulsion. If you look at the ingredient list on a chocolate bar, you'll see lecithin, which is an emulsifier. What this means is that it's a substance that breaks up the cocoa butter into tiny droplets that can be evenly mixed into the chocolate as it is being made, and it'll stay dispersed in the chocolate as it hardens rather than collect into little fat globules. So given a sample of matter, you can ask yourself, does this have constant properties and composition throughout? If you answer yourself yes, then you have a substance. At which point you would then ask, can it be simplified chemically? If you answer yes, then you have a compound. If you answer yourself no, then you have an element. If the answer to the question, does it have constant property and composition throughout, is no, then you have a mixture. At which point you would then ask, are the components uniformly distributed throughout? If you answer yourself yes, then you have a homogeneous mixture. If you answer yourself no, then you have a heterogeneous mixture. Today's episode was brought to you by the element hydrogen.
Hydrogen was discovered by the English physicist Henry Cavendish in 1766. He discovered that it forms water when burned in the presence of oxygen. It was given its name by Anton Laurent Lavoisier due to this fact. Hydro, meaning water, gen, meaning to make or generate. Hydrogen. Hydrogen is one of the 7 diatomic elements. It is a gaseous element that is colorless, odorless, non-toxic, and highly combustible. It is the most abundant element in the universe, making up 75% of its composition. It is the main fuel source for stars like our Sun. Hydrogen forms many compounds with carbon called hydrocarbons, and there are millions of different compounds of this type. It is the least dense element, and as a result, it was much sought after for lighter-than-air aircraft, with the first passenger-containing balloon being flown in 1852. Although hydrogen is still used in weather balloons today, its use for commercial transportation ended when the Hindenburg caught fire and crashed in 1937.
Thank you for watching my video. I hope you found it both informative and interesting. If you did, please smash that like button below and consider subscribing and hitting the notification bell so you know when my next video comes out. When it does, please join me again. Until then, be good, be careful, and don't trust atoms. They make things up.